Hello and welcome children. Today it is second class of integrals. In first class we studied fundamental of integrals. Children, if you have to find integral of 1 by x, then what will be the answer? Answer will be log of x onto the base e plus c. You can cross check it also. If we will differentiate log x, then we will get 1 by x. Similarly, if I ask you what is the integration of 1 upon 1 plus x square, you can give answer immediately, that is tan inverse x, because these two are the derivative of some function. 1 by x is derivative of log x and 1 upon 1 plus x square is derivative of tan inverse x. But if I ask you what is the integration of log x by x, then you can not tell immediately that what will be the answer. The reason is because we do not know it is the derivative of which function. So this fundamental method of integral, it is failed here. Clear? See one more example. If I ask you find the integral of sine root x by root x, then you cannot tell it immediately because it is not a derivative of some function. Clear? So to find the solution of problem like these, we have techniques of integration. The first technique of integration is integration by substitution. You see how substitution help us. We see the same example, integration of log x by x. So what we can do, let log x equal to t, differentiate both sides with respect to t. Log x, that is 1 by x, derivative of x dx by dt, and derivative of t 1. So we can write it 1 by x dx by dt equal to 1. Take it this side. It will be 1 by x dx equal to dt. Put the value here. Log x equal to t, and what is dx by x, that is equal to dt. So we have converted variable of integration. Earlier the variable of integration was x. Now the variable of integration is t. Now what is the integration of t? That is t square by 2. Put the value of t, log x whole square by 2 plus c. And you can cross check also this. How can you cross check? Differentiate this and you must get this out. This method is called integration by substitution. Clear? See one more example. Integration of 2x upon 1 plus x square. So it cannot be integrated directly. So what we use? We use substitution. Let 1 plus x square equal to t. Differentiate both sides with respect to t. Derivative of 1, 0. X square 2x, x dx by dt, and t 1. We can write it 2x dx equal to dt. Put the value 2x dx equal to dt. 1 plus x square t. Clear? Now integration of 1 by t is log t plus c. Put the value of t, that is 1 plus x square. Understand? See one more. Integration of log x whole square by x. Now you have to learn the technique of substitutions also. First of all, we have to take a function t such that other part is derivative of that function. As you can see here, derivative of log x is 1 by x. So we will take log x equal to t, differentiate both sides, put the value t square and dx by x dt. Integration of t square t cube by 3 plus c, put the value of t, log x whole cube by 3 plus c. This is the answer. Clear? A substitution is successful if whole function is converted into t and dx converted into dt, and we are able to use some fundamental formulae on this. Then only substitution is successful. Otherwise, you can change substitution, means you can take another function as t. I hope it is clear. Similarly, you can see here what is common here, x. So 1 by x is derivative of log x. So what we will do? We will take 1 plus log x equal to t. Same way. Then 1 by x dx equal to dt. Put the value and we will get the answer. Clear? This question you can solve yourself. Now see here, one part is square root, other part is without square root. So most of the time whenever root is there, we take root part as t. So let root 1 plus 2x square equal to t. Squaring both sides, it is t square. Now differentiate 4x dx equal to 2t dt. So x dx equal to t by 2 dt. Put the values here. What is the value of root 1 plus 2x square? T. And what is the value of x dx? T by 2 dt. That is t square. Integrate, put the value of t here. I hope it is clear. So like this you can solve here. So which part will you take as t? This part. We'll take this part as t. Okay. And we have to convert whole x into t. Next, which function will you take as t? Root x plus 4. So root x plus 4 equal to t. Then x plus 4 equal to t square. Sometime you can take x plus 4 also t. That is your choice. So this also you have to solve yourself. Now next. Now here we are not able to identify immediately that which function is to be taken t. So what you have to do in beginning, you can take any function as t. Whatever you feel, you can take as t. Let us take x cube minus 1 equal to t. Differentiate both sides. So x square dx will be equal to dt by 3. So put the values here. What is the value of x cube minus 1? T power 1 by 3. Split this part x power 5 into x square into x cube. So what will be the value of x cube? That will be t plus 1. And what will be the value of x square dx? Dt by 3. It means whole function is converted in terms of t and variable of integral is converted into dt. So this substitution is successful. Now you can integrate it very easily. Multiply this t power 4 by 3, t power 1 by 3. Now you can integrate. Okay. Similarly, here you can see 1 by x, it is derivative of log x. So you have to take log x as t. Next, try to identify now tan inverse x. If we take it as t, then what is the derivative? 1 upon 1 plus x square. So we can take tan inverse x as t, but we cannot take 1 plus x square as t, because what is the derivative of 1 plus x square? 2x dx, but 2x dx is not present here. Clear? So we will take tan inverse x as t, differentiate, put the value here, tan inverse x t and dx upon 1 plus x get dt. Integration of e power t, and this is the clear. Now it is one of the very special question. Many times it is there that we have to manipulate the function and simplify it in such a way that we are able to use fundamental formulae. Here the trick is divide numerator and denominator by e power x. It becomes e power 2x plus 1 upon e power x. E power 2x divided by e power x, that is e power x, and this become e power minus x. Similarly, e power x, e power minus x. Now easily we can see this numerator is derivative of denominator. So what we can do, we can take this denominator as t, differentiate, put the value, and you will get the clear. So many time multiplying or dividing by some function make the integral easy to integrate. Clear? Now see in this question tan square 2x minus 3. So tan square 2x minus 3 can be written as sec square minus 1. And what is the integration of sec square? That is tan 2x minus 3 divided by coefficient of x, and integration of 1 is x. No need to make any substitution. Although you can do by substitution, but here it can be done directly also. Clear? Now there are few more fundamental formulas. Please see that. See one result. See one very important result. Integral of f dash x upon fx equal to log of fx. Means if numerator is derivative of denominator, then its answer is log of denominator. You can verify it also. Let fx equal to t. Differentiate both sides. So f dash x dx become dt fx t. And what is the integration of 1 by t? Log t. Put the value of t equal to fx. So it is log fx plus c. In future, we will use this result directly. F dash x upon fx is equal to log of denominator means fx. Clear? You can see one example here. Question number 38. Integrate. So what we observe here? What is the derivative of x power 10? That is 10x power 9. What is the derivative of 10 power x? That is 10 power x log 10. It means numerator is derivative of denominator. So direct you can write log of denominator. Clear? Or you can do it by substitution also. Either you can use substitution or you can use direct result. What is the direct result? If numerator is derivative of denominator, then log of denominator. See this question. What is common here? 2. Now see these two parts. What is the observation? Derivative of 3 cos x minus 3 sin x, 2 sin x, 2 cos x. So numerator is derivative of denominator. So answer half log of denominator. Here also you can see 1 by cos square equal to what? Sec square. Now sec square x is derivative of 10x. So take 1 minus 10x as t. Simple calculation is there. Here you have to take root 1 plus sin x as t, or 1 plus sin x can also be taken as t. Now here we are not able to identify quickly what to take as t. So you can take this log sin x as t. Why we are not taking cot x as t? Derivative of cot x is minus cos x square, but minus cos x square x is not present there. So we have to take log sin x as t. Clear? So cot x dx equal to dt. Put the values here and you will get answer. Now there is one more very special problem. Integral of 1 upon 1 plus cot x. So cot x can be written as cos by sine. Take LCM. Whenever there is sine and cos in numerator and denominator, there is one specific method for this. Try to make a function same as denominator in the numerator. So what we do, multiply by 2, divide by 2. 2 sin x can be written as sine plus cos. 2 sin x can be written as sine plus sine, plus cos and minus cos. Now we can write it separately, this by this by this cancel, and check this second part. It is the derivative of denominator. So what is the answer? Log of denominator. Clear? Whenever there is 1 upon 1 plus tan, 1 upon 1 minus tan, 1 upon 1 plus cot, 1 upon 1 minus cot, this method is very helpful. See one more example. Tan can be written as sine by cos. Take LCM. Multiply by 2, divide by 2. 2 cos x can be written cos plus cos minus sine plus sine. Write it separately. This part will be the derivative of this, and integration of 1 x. So log of denominator. Clear? Now here one more question. Integral of root 10x by sine cos x. So again we are not able to identify what to take as t. So let us try by taking root 10x. Let root 10x equal to t. Differentiate both sides. 10x equal to t square. Sec square x dx equal to 2t dt. But sec square is not present there. So what we can do? Multiply by sec square and divide by sec square. So sec square can be written as 1 by cos square. This 1 cos cancel. Sec square x root 10x and sin x by cos x is 10x. So finally it becomes sec square x dx, and 10x by root 10x is root 10x. Now put the value. Sec square x dx equal to what? 2t dt, and root 10x equal to t. So the integration 2t plus c. Put the value of t, that is root 10x. So many times, as I told you, multiplying and dividing by the same thing can be very, very helpful. Clear? Here you have to take x plus log x as t. Next, try to identify now tan inverse x power 4. What is the derivative of tan inverse? 1 upon 1 plus x square, which is present there. And what is the derivative of x power 4? 4x cube, that is also present. So take tan inverse x power 4 as t. Clear? This question we have done already. So children, it was the first technique of integration, which is known as the integration by substitution. Clear? It is very, very important, and it will be used for further methods also. On the basis of this, you can do second exercise of NCERT. Till then, goodbye.